Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I want to give you a code review for a Kaggle Community Competition question. It's called Beginner's Prediction Task, and personally, I wouldn't really consider it a beginner's prediction task, but anyway, that's what they call it, a beginner's prediction task, because it had a lot of white space in it, so you had to remove the white space. And it just, like, the data wasn't perfect. So if I was going to give somebody a beginner's prediction task, I would give them a different task than this. But that's what they call it. So I ran it up on Kaggle, and my best score was 3.69. But and then the score for this particular notebook was 3.78. And I tried to use different nodes, and then I tried to use a different optimizer to see if I could improve my score. But this is what I got, so this is what I decided to go ahead and do a code review on what I've got for this particular competition question. The problem statement is predict students' grades. More specifically, you're predicting their GPA, their grade point average. And we created the Jupyter notebook in Kaggle, which is a free online Jupyter notebook. So once we created the notebook, what we want to do is we want to import the libraries. So what we're going to import to begin with is NumPy for NP. That's going to create your NumPy arrays and do NumPy calculations. We created Pandas SPD. That's going to create your data frames and process the data. We created OS, which goes into the operating system. We created, imported matplotlib.pyplot.splt, which provides your graphics, and we imported Seaborn as SNS, which provides the graphics statistically. We also imported within the program SciPy, which is a scientific calculation library, and it performs statistics. We imported sklearn, which provides machine learning functionality, and then of course we imported TensorFlow, which creates your neural network. So after we've imported all of the libraries, what we want to do is we want to get the files. And so we're going to use OS to get the files. And then we've got three main files, which are train, test, and submit. Those are the three main files that we're using. We use Pandas to read in those files and create data frames, and we call them train, test, and submission. So we want to look at the train file. So we want to see all of the columns. So pd.setOption, display.max columns, then none. And then so you can see all of the columns here. And the column that we're most interested in is the GPA, because that tells you the grade point average. You had 340 rows by 32 columns. We checked the info to see what kind of columns that we're working with, and you see we had 31 columns, or really I think 32 columns, because Python starts with 0, so really it was 32 columns of data, and the last column being the GPA, which is a float. So we checked out for null values, and we had 7 null values in attendance percentage. So what we did was we just dropped all of the, since there were only 7 null values, we just dropped all of the rows that had null values, and it was train.drop in place equals true. So you can see that we just dropped the null values. So now you have 333 rows by 32 columns. So now we check the test. Test is similar to train with the exception that there's no GPA. That's what we're going to predict on. We check for null values. We don't have any null values, so we don't have anything to impute. And then we check submission. So the submission wants to see the ID and the GPA. So now what we're going to do is we're going to use SciPy, and we're going to use the Kaggle 2-sample test, or Kaggle. Let me see if I can find it. Kolmogorov-Smirnov 2-column test. That's what we're going to do. And we're going to see if the train test and the test are from the same distribution. So we're going to create a blank array called toDrop for column in test, stat, pv equals stats.ks underscore toSamp, and then it's going to be train call and test call. If pv is less than 0.05, you print the column is not drawn from the same distribution, and then you go toDrop.append call, and then we print toDrop. And in this instance, all of the columns of data in the test set appear to be from the same distribution as the train set. But that's always something that you need to check, because if a column of data isn't from the same distribution, it's going to affect your predictions, So I just delete the columns of data that are not from the same distribution. There's also a lot of white space, which I found that out because I've been working on this problem since yesterday, even though it was supposed to be a beginner's problem. So for call in train, if train call.dtop equals object, train call equals train call dot string strip, test call equals test call dot string strip. And so basically what you're doing is you're just getting rid of all the white space, because there's lots of white space in the data frames, and because there's white space in the data frames, it's going to affect your outcome. So you want to get rid of that. We're going to remove the ID and the name from the data frames because you don't need it. The reason why you don't need it is because every row is indexed in a data frame, in a pandas data frame. Now what we're going to do is we're going to analyze gender. So we want to know the genders. Print train gender unique. So these are the unique values in gender. And so you can see they said male, female, F, and male. So what we had to do is we had to create a dictionary. So train sex equals train gender map sex. Test sex equals test gender map sex. And then so we drop the gender column because we don't need that anymore. We create a box plot, and you can see that the females' grade point averages were higher than the males. Now we check for ethnicity, so you can see that the train has more ethnicity than test. I think it's Ibibio is what is not in the test set, but there you go. So we created a box plot of ethnicity, and so you can see that the Yoruba had a higher ethnicity than the others. So that had a higher grade point average. So that's interesting. Now we're going to check the religion, and you can see the Christian religion had a higher grade point average than Islam. And now we're going to check the state of origin, and so you can see the state of origin. So it looks to me like Kaduna has a higher grade point average than everything else. So your ethnicity depends on your grade point average. And now we check the age. So the ages were 15, 16, 17, and 18. Somebody had put a -2 in there and a 0 in there. And so what we did was, since they occurred only once, what we did was we just removed the columns where the value occurred only once. And the reason why is because you're not going to have somebody who's -2, and you're not going to have somebody who's 0. We filtered that out, so now we only have 331 rows of data. So we check our age again, so it's 15 to 18. So you can see, look at the grade point averages, and you can see the 18-year-olds had the higher grade point average. So now we're checking the unique, the hobbies. And so these are all of the hobbies in the train file. And so we created a box plot of the hobbies. So you can see playing basketball, dancing, playing football, reading books, singing, painting, and coding. It looks like coding scored a little bit better, really, but there you go. Because you have to be really, you have to work really hard. You have to spend a lot of time on your own learning to code. It's not something that's really easy, because that's what we're doing here in this video, is we're coding. And I'm also going to be expanding my coding. I'm going to be moving on from Python, although Python is going to be what I'm going to be doing mostly, because that's what Kaggle is on. But I'm going to learn other programming languages too as well, because I've been working on Python for about 3 years, and maybe it's time for me to move on, who knows. And so now we check to see if they have a learning disability. What's interesting is if they had a learning disability, they scored higher. So that was interesting, but maybe that was because they were put in easier classes. Maybe they were put in easier classes, which gave them a higher grade point average, who knows. Now we talk about the type of school. You had a government, public, and private. It looks like the grade point average was higher in a government school, which is interesting. The private school wasn't. The private school fared just slightly better than the public school. So people who think they put their children in private schools aren't necessarily getting the best education, but who knows. Now what we're going to do is we're going to check the school location, whether it's suburban, urban, or rural. And the urban schools were higher grade point average than the suburban and rural. The rural schools had a less grade point average, which is interesting. Now we're going to check the parental education level. So the parents who attended tertiary education had a higher grade point average than those that didn't, which was interesting. A tutor mentoring program. The students who attended a tutor mentoring program had a higher grade point average than those that didn't, which was interesting. Parental involvement level. The parents who were involved in their children's education, the children had a higher grade point average, which was interesting. And I find that interesting because my parents were not interested in my education, and so I didn't do as well as I could have done. But hey ho, that was a long time ago. Bullying experience. Children bullied scored better than children that were. That's interesting. And now we created a scatter plot of attendance percentages. So the children who attended school more had a higher grade point average than those that didn't, which was interesting. Now we check study time. The children that study time, we're going to say 5 hours a week or something like that, they scored better, or 7 hours a week. Yeah, children that studied 7 hours a week. I don't know if it was like days a week or hours a week, but students that studied 7 that had a higher grade point average than everybody else. So the more you study, the better the grades. And I don't know, I study Python and science an awful lot, so I don't know. Then you got your motivation level. So the higher the self-motivation level, the higher the grade point average, and so we had a self-motivation level of 8, and that seemed to be the highest. And you got your study environment rating. So people who had a study environment of 4 had the highest grade point average. went through to drop it at the very end, and it looks like that it didn't do that when I was going through it. So that's a good thing about going over the code, because I can think, oh, I didn't do this and I didn't do that. So we're going to encode the object columns. We're going to use SKN's ordinal encoder to do that. So if it was an object, we encoded it. And I'm also going to give you the link to the Jupyter notebook in the description box down below. And so now we're going to create a heat map. And the heat map we created is going to be numeric only equal true. So you can see that some of the columns have a higher correlation than others. So here's your correlation if you want to see the correlation. And so I decided to drop all of the columns that have high correlation, or correlation of greater than 0.15. So we dropped exam math and exam English, but I think I'm going to drop exam social science as well, because they have outliers in it. Now what we're going to do is we're going to define our x and our y variables. So y equals target, which we've already defined, x equals train, x test equals test. So I was having some problems getting it working. So there's your y, there's your x, and there's your x test. Now we're going to use train test split to split the x and y variables into training and validation sets. And now we're getting into TensorFlow, where we're creating our neural network. And we can import the libraries for TensorFlow. What we want to do now is we want to standardize the data. It says normalization in TensorFlow, but to me it's really standardized. And then after we standardize the data, we're going to create our neural network. And so there you go. We're going to create a sequential neural network and call it GPA. The first row of the neural network is going to be the normalizer, and then we're going to have the human layer, which I made it 25 neurons. And the second human layer is also 25 neurons. And then I made one advanced layer of 1 neuron, which is your output layer. So we're going to compile it. I decided in this one to use RMS prop, which means mean squared propagation. Normally we use Atom. I thought I'd try mean squared propagation to see if it would improve my score. And then we set it up for early stopping and model checkpoint. And we ran it for 200 epochs, and it is going to stop learning. So when it stopped learning, we had to